Hello everyone, my name is Joyce Osai Hama, a master's student studying cloud computing at the University of Lincoln, and my student ID is 27306002. This is a demo of my cloud-based AI support application built for a financial institution use case. The application includes both front-end and back-end implementations, API integrations with Stripe and Mistral AI, a credit queuing notification system, and secure user authentication and authorization. The application has been deployed to Docker, and this demonstration will show the application being run from its Docker containers. The backend is built using Python's Fast API, exposing endpoints for user registration and authentication, while protected endpoints require authentication and authorization before they can be accessed. This application uses JWT tokens to protect routes and endpoints. The front end is built using Angular, a JavaScript framework. I will attempt to register an already existing user to show the application intuitively gives the correct error message to the client side. As we can see, the application prompts the user with a message that tells the user that the user details already exists. I will now register with non-existing credentials. Also, the front end has input field validations to prompt the user when they are making a mistake with either the password or, for example, the first name field. After successful registration, users are redirected to the login page so they can log in securely. In future sprints, email verification will be added to ensure registered users are who they say they are and provide more security to the application. I will attempt to log in with wrong credentials. Here we can see what happens when incorrect credentials are used. Authentication fails, ensuring only authorized users access protected endpoints. Before I proceed with correct credentials, to enforce secure user data handling between the exposed endpoints, that is the register and the login endpoints, AES encryption was used to encrypt the request and response objects between the front end and the back end to protect users from threats like man in the middle attack. On successful login, the user is routed to the chat interface. The user's username is added to a personalized greeting with the time the user has logged in. The application uses a credit-based model. Credits are required to submit AI queries, and credits are also deducted per query. Users can view available pricing plans here and purchase credits with Stripe. Users are also given a total number of 20 free credits on successful registration. I will log out now and attempt to log in with a user that has 0 credits. This user currently has 0 credits. Let's try to submit a query to the AI. As you can see, a toaster alert virtually prompts the user that they have insufficient credits and their query has been pending. They also get a notification alert that they have a new notification. And also AI responds with a personalized message: "Dear Precious, you have insufficient credits and your query has been queued." In the notification page, users receive alerts for multiple actions. A user can also mark the notification as read, and this trigger a visual toaster alert using Angular. Currently, we have an admin dashboard, and the admin is only able to view user metrics by monitoring the number of registered users, users that have purchased credit, and users with low credits. In future sprints, admin will be able to push important notifications to users and users with low credits with the integration of Firebase cloud messaging service. Admin will also be able to view and manage the queues for escalation. I have previously demonstrated a user submitting a query with no credits. I'm logged in as this user now with no credits, and I will proceed to demonstrate the purchase from Stripe. On successful purchase, the user is given 50 number of credits because that's what the user purchased. I will now send a message to the AI. Queries are sent to Mistral AI asynchronously using Fast API's background task. It constantly checks the database for pending or processing queues. The AI is configured to behave like a banking support agent, secure and never requesting for sensitive information. If an account number is added in the query, the AI responds and tells the user to contact a bank representative. I will demo that now. As you can see, the AI responds with, "For security reasons, I can't discuss sensitive information like account numbers. Please contact a bank representative." Aside sensitive information, the AI responds to every other query and offers solutions to the user. As you can see, the AI responds offering solutions to the user for why they cannot make a transfer. Currently, both user queries and AI responses are stored in the database but not on the client side due to security reasons. In future sprints, users will be able to view chat history between themselves and AI after inputting passwords and going through multiple factor authentication to access the feature. Now, the user can end the chat to clear off conversations before logging out. For the documentation, I used Swagger API, Swagger UI, and Redoc. Fast API's built-in Swagger and Redoc allows developers to easily explore and test endpoints and also show example of API usage. For my end user documentation, I wrote an automated documentation using Sphinx as it integrates very well with Fast API. This provides guidance on how to use the platform and its features with pages like getting started, pricing, API design, frequently asked questions, and some of the modules in the application. In the application, a dedicated web page is shown is has been designed to show the system's architecture. It also shows some of the API endpoints, request and response objects. Once again, JBAI support is built using JBAI support application is built using Angular for the front end, Fast API for the back end, and PostgreSQL is used for data persistence. Docker Compose is used for deployment in containers, and the system is designed to scale efficiently. In summary, this is a full stack AI support application designed to assist users in a secure and intuitive manner. It incorporates the integration of cloud APIs, secure user management, credits, queues, and notification systems, and documentation for both developers and end users in mind. Thank you for watching this demo.